Okay, we just have a very little bit left today, and those are hydroxide. Okay, most polyatomics end in 8 or ite. Okay, there are 2 exceptions, and those are hydroxide. Hydroxide is OH minus. It is not H minus. It's not O minus. Okay, H minus is hydride. I guess it would be O2 minus. O2 minus is oxide. O8 hydroxide is neither of those. Hydroxide is an oxygen bonded covalently. Remember, it's between 2 nonmetals. It's sharing electrons. Okay, and there we go. Okay, hydroxide is OH minus. The other one is cyanide. Okay, and it is, I can't think what you would think cyanide would be. There's no element that sounds like cyanide. You will not find it on the periodic table. So it is not on the periodic table. You'll not find, what would you call it? I don't know. Cyanogen? I don't know. Anyway, you won't find it on the periodic table because it is a polyatomic ion, and so you'll find it on the chart of polyatomic ions. Okay? And just so you know, where would we find hydroxide? Hydroxide is a super common thing. Hydroxide makes things basic. Okay? If you have hydroxide ion, things are basic, which is the opposite of acidic. Okay? And you may have heard of lye or caustic soda. And lye or caustic soda is sodium hydroxide. And bases always feel slippery. Okay, so it is used in soaps, it's used in cleaners. Why is that? Because it makes things slippery, and so everything will just wash right off. It has some other properties as well, but that is one of the reasons that we use it to help make soaps, is that it is slippery and things will just slide off. Okay, it's used in food preparation. Yeah, you'd have to dilute it a lot, otherwise it would eat right through you. Excellent. Potassium cyanide, if anyone reads any Agatha Christie, she's a mystery writer, writes cozy British mysteries. She's sort of the grand dame of mysteries. She used cyanide in a lot of her poisonings. Okay, let's finish up by naming some of these. If we have sodium hydroxide, that's Na plus and OH minus. I'm going to rewrite these so I can see them better. No, I'm not. We have Na plus and we have OH minus. You'll notice that the net charge there is already 0. Plus 1 and minus 1 gives us an overall charge of 0. So we just need one Na and one OH. Notice we have one OH only, and therefore there are no brackets. Okay? If you're worried at this point, if you're thinking, oh my God, I need to know all about my brackets now. I need to know, oh my God, this is just a taste of it. We aren't actually officially learning how to write the formulas yet. You're just getting a flavor of it. So relax. I know there's a few of you out there who are prone to panic. Stop panicking. This is just to introduce you to the names and to have seen things a few times before we actually learn it. Okay, so don't worry about the brackets. Just be kind of like, okay, I've heard of brackets before. Okay, I'm good. All right. Okay, barium hydroxide. I have a typo here. This should, I've got barium. Let's make that a little bit bigger. Oh, come on, move over. Barium is 2+. Hydroxide is -1, and I think I typed this wrong. That should not be Cn, that should be OH minus. Okay, my total positive charge is 2 positive. My total negative charge, -1 and -1 gives me 2 minus. If I add those up together, I'm going to end up with that overall 0 charge. Remember, all compounds have a net charge of 0. All compounds have a net, which means overall charge of 0. Nature does not like leftover charges. In this case, we have Ba, and because we have 2 of them, we have to put it in brackets. Okay, people have a tendency to forget the brackets here because it's really easy to write BaOH2. The problem with this one is this would mean you had 1 barium, you have 1 oxygen atom, because the oxygen does not have a 2, okay? And you would have 2 hydrogens. But if we actually go back and look, we have 1 barium, we have 2 oxygens, not 1 oxygen, we have 2 oxygens. That looks like 20s. That's not helpful. We have 2 oxygens and we have 2 hydrogens. So we need to say that we have both 2 oxygens and 2 hydrogens. How do we do that? When we put the 2 in the brackets, it applies both to the O and to the H. That means that I have 1 barium, 2 O's. I wish O didn't look like a 0. 2 space O's and 2 H's. Okay? We can take a look at iron 3 hydroxide. Remember that 3 does not mean that we have 3 irons. That 3 tells us the charge of iron. Okay? Remember the Roman numeral tells us the charge of a single ion. So if it says iron 3, that's not Fe3, okay? No. What it means is that we have this 3 right here, okay? 3+. In order to have a neutral compound, we're going to have -1 plus -1 plus -1, giving us a total of -3. 3 positive and 3 minus is going to give us an overall charge of 0. And again, in order to have 3 oxygens and 3 hydrogens, this has to go in brackets. Okay, so that we get both 3 oxygens and 3 hydrogens. It's not going to be FeOH3. That would only be 1 oxygen, which would be bad. Okay? There we go. Okay. Potassium cyanide. Potassium is +1. Cn is -1. So KCN. Only 1 Cn minus Therefore, no brackets. Okay. Strontium, Sr2+. So I need to have 2 of the cyanides, and again, to give me -2 to balance out the +2, because there are 2 of them, it has to go in brackets. And gold 3, remember that does not mean that we have 3 golds. No, it means that the charge of the gold is 3+. Okay? That 3 right there tells us the charge of the gold. All right, and that means we need, if each cyanide is -1, we need 3 of them to give us a total negative charge of -3. And so what we have now is we have 3 cyanides, and again, it has to go in brackets so that we have both 3 of the carbon and 3 of the nitrogen. We do not want to have AuCN3 where that 3 only applies to the N, because as you can see, we have 3 carbons as well.